So when they tell you it's a regular hexagon, they're giving you some key information. Regular means it's both equilateral, so all the sides are congruent, and also equiangular. That means all these angles are congruent all throughout. And we could keep going all the way around. So if this is 60, then this is also 60. And the concept there is that, okay, this must be at a minimum an isosceles triangle because of base angles theorem. Maybe I'll use double tick marks there because we don't technically know if it's congruent to this side here. However, as we'll see in the back side of page 34, so side 4 of our math reference document, which is dedicated exclusively to geometry concepts, notice we have triangle sum theorem, which says that the sum of all 3 angles in a triangle is 180. And the reason that's significant is if these two already add up to 120, 180 minus 120 gives us 60. So look at that. It ends up being an equilateral triangle. So I'll erase these double tick marks and just make them single because they're all congruent to each other. And then we have an important concept of vertical angles versus linear pairs. So when you have 2 lines intersecting, the angles that are essentially across from each other, either vertically or horizontally, are called vertical angles. And the conclusion is that they're congruent to each other. So in this setup here, these angles are congruent to each other, which makes alpha 60.